Students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing this chapter called as semiconductors. Let's see the working of an oscillator. Let's draw an oscillator circuit first. Now an oscillator circuit consists of an inductor and capacitor connected in parallel. An inductor and a capacitor connected in parallel is called as a tank circuit. So this is my tank circuit. Which is then connected to an amplifier. Which is then connected to a feedback network. Which is then given back to the tank circuit. The output of the feedback network is given to the tank circuit. Okay. Now let's see the working. So I can say that this is how your signal would move. I can say a transistor amplifier with proper positive feedback can act as an oscillator, right? Now this particular diagram that I have drawn is a diagram of a feedback LC oscillator, where this is the inductor, this is your capacitor. Now let's see in detail how the entire circuit works. Right? I can say first part of the circuit is the tank circuit. Right? Now, how does the tank circuit work? The circuit which produces the electrical oscillations of any desired frequency is known as the tank circuit. The circuit that produces electrical oscillations of any desired frequency is known as tank circuit. Right? Now, it consists of a capacitor and an inductor in parallel. It consists of a capacitor and inductor in parallel. So you have a capacitor and an inductor that is connected in parallel. The frequency produced by the tank circuit is determined by the value of L and C. Now, capacitor stores the energy in its electrical field. How does this work? Capacitor stores the energy in its electrical field Capacitor stores the energy in its electrical field. In LC circuit, the capacitor discharges through the inductor. In LC circuit, capacitor discharges through the inductor. Right? Now, if the capacitor is going to discharge through the inductor, this will set up a magnetic field in the inductor. So this sets up a magnetic field around the inductor. This sets up a magnetic field around the inductor. When the capacitor fully discharges, when the capacitor fully discharges, the electrostatic energy of the capacitor is completely converted into the magnetic field energy around the inductor. As it discharges, it will go on producing magnetic field in the inductor. By the time it fully discharges, an entire magnetic field is going to be produced in the inductor. So I can say that when the capacitor fully discharges, the electrostatic energy of the capacitor, the electrostatic energy of the capacitor is completely converted into magnetic field energy, completely converted into magnetic field energy around the inductor. Fine. Now, once the capacitor is discharged, the magnetic field collapses. Once the capacitor is discharged, the magnetic field collapses. Hence, a counter EMF is developed in the inductor. Hence, a counter EMF is developed in the inductor. Which now charges the capacitor in the opposite direction. The capacitor again the capacitor discharges, but now the current flows in opposite direction. Again the capacitor discharges, but now the current flows in opposite direction. Right? Thus, energy is alternately stored in the electrical field of the capacitor and the magnetic field of the inductor. Thus, energy is alternately stored in the electrical field of capacitor and magnetic field of inductor. Fine, do we get this thing here? This results in the production of oscillatory current. This results in the production of oscillatory current. Right? Now see, I could show you this way, right? Suppose I have an inductor and I have a capacitor here. You have an open circuit initially, hence you would have charge that would be there on the capacitor, right? Now once I close the circuit, so this is my diagram 1. Once I close the circuit, guys, inductor, capacitor, the capacitor would discharge through the inductor, right? Hence, here the capacitor would discharge through the inductor, hence a magnetic field would be set up in the inductor. This is going to set up a magnetic field in the inductor. This is my phase 2. Initially it's an open circuit, then the circuit closes, which creates a magnetic field in the inductor, as a result of which, if I were to see a diagram, this is the voltage that would be produced with time voltage, right? Now then once the capacitor is fully discharged, guys, once the capacitor is fully discharged, the inductor would then charge the capacitor in the opposite direction. Hence, inductor, capacitor, the circuit is still closed, right? Now, the capacitor is now going to be charged in opposite direction, as a result of which the inductor is going to charge here. The inductor charges the capacitor in opposite direction. So we already had a current like this. You will have voltage like this. So you would have positive cycle. Then the capacitor would now set up a magnetic field in the inductor in the opposite direction. Because it has been charged in the opposite direction, obviously it will set up a magnetic field in the inductor in opposite direction. So here you would have a magnetic field that would be set up again in the inductor, right? But this magnetic field is now going to be set up in opposite direction. Here the magnetic field, say, was in a particular direction. So now the magnetic field will be in opposite direction. So as a result of which, you already had half a wave in the opposite direction, and thus the process continues. That's exactly what I've written in the theory, right? Initially the capacitor gets charged with the DC current, right? The capacitor discharges through the inductor, right? As it discharges, due to Lenz's law, you would have EMF that would be produced. Once the capacitor is totally discharged, then there will be a magnetic field that will be produced in the inductor, and that magnetic field will produce an EMF that will charge the capacitor in opposite direction. So now the capacitor would be charged in opposite direction, right? Once the capacitor is fully charged, there would be no magnetic field in the inductor, therefore the capacitor will now discharge again through the inductor. But this time when it discharges through the inductor, it is going to discharge in opposite direction because it was charged in opposite direction. Hence, again a magnetic field will be set up, but now the potential will be in opposite direction. So do you understand how a tank circuit works? Now, do we understand the entire theory of the tank circuit? The frequency of the oscillation produced by the circuit F0 is going to be 1 upon 2 pi root LC. That means the circuit has to be at resonance. Now if there were no losses in the tank circuit, the oscillations would continue indefinitely. If there were no losses in the tank circuit, the oscillations would continue indefinitely. The oscillation would continue indefinitely, but in a practical tank circuit, there is resistivity and radiation losses, but in a practical tank circuit there is resistivity and radiation losses in the inductor. Resistivity and radiation losses in the inductor. There is resistivity and radiation losses in the inductor and dielectric losses in the capacitor. And dielectric losses in the capacitor. Right? So as a result of this, during each cycle a part of the energy is used to overcome these losses. Right? During each cycle a part of the energy is used to overcome these losses and the amplitude of oscillation will finally go on decreasing and become zero. Will finally go on decreasing and become zero. Will finally go on decreasing and become zero, which is called as your damped oscillation. Fine, do we get this thing clear? So how this will appear is like this. Right? This is my plus I max, this is minus I max. Maximum current in positive and negative direction. So your current would now be like this. Due to a part of the energy being spent in overcoming the amplitude, you would have damped oscillation. Fine, do we get this thing clear? Right? Now, that is the reason why you would require an amplifier. The second part of the circuit is an amplifier. The first part of the circuit is your tank circuit. The second part of the circuit is an amplifier. Why do I need an amplifier? The function of the amplifier is to amplify the oscillations produced by the LC circuit. Right? Function of the amplifier is to amplify the oscillations produced by LC circuit. Right? These oscillations produced in the tank circuit are applied to the input of the transistor. These oscillations produced by tank circuit. These oscillations produced by tank circuit are applied to the input of transistors. Right? The transistor amplifier increases the amplitude of oscillation. right? The transistor amplifier increases the amplitude of oscillation. So that was the second part of an oscillator circuit. So you are a tank circuit, you have an amplifier. The third is a feedback circuit. The next thing that you have is a feedback circuit. Now, to produce continuous oscillation, it is necessary to supply the correct amount of energy to the tank circuit, which should be in phase with the oscillations of the tank circuit. We saw that the output of the tank circuit is a damped oscillation. I don't want a damped oscillation. I want continuous oscillations. So I can say that to produce a tank circuit produces damped oscillation. A tank circuit produces damped oscillation. To produce continuous oscillation, to produce continuous oscillation, it is necessary to supply, correct amount of energy to the tank circuit. It is necessary to supply correct amount of energy to the tank circuit, which should be in phase with the oscillations set up by the tank circuit, which should be in phase with the oscillations set up by the tank circuit. Right? This function of the the function of the LC feedback circuit is to transfer a part of the output energy to the tank circuit in phase with the oscillations of the tank circuit so as to provide a positive feedback. Fine, do we get this in here? This is what my feedback circuit does, right? The function of LC feedback circuit. Your feedback circuit is also a tank circuit. So the function of the LC feedback circuit is to transfer a part of the output energy, in phase with the oscillations in the tank circuit. In phase with the oscillations in the tank circuit, so as to aid these oscillations, or so as to provide positive feedback. Now, because of the positive feedback that is provided, instead of having a damped oscillation, you will get a continuous undamped oscillation. Fine, do we get this in here? What you would get in your output would be plus Imax minus Imax. Instead of getting a damped oscillation, you will get and undamped oscillation. This is the kind of circuit that you would get, right? Do we understand this? So that's the reason why I need a feedback circuit, right? Now, the transistor amplifier should produce a phase shift of 180 degree, and the feedback network should again produce a phase shift of 180 degree, so that there's a total phase shift of 360 degree. Hence, the feedback signal in that case will be in phase with the input signal of the tank circuit. It is also necessary to provide the correct amount of energy to make up for the losses. Hence, the beta factor and the voltage gain of the amplifier should be correctly set, so that the voltage gain, the product of the voltage gain and the current gain is equal to 1, right? So under such circumstances, a tank circuit would produce an undamped oscillation, right? So this is how an oscillator works, right? We'll stop this here for the day. Thank you very much.